Hello and welcome. Today we get into section 9.1 on polar coordinates. So this is as opposed to rectangular coordinates, form of xy. Or just the distance from the y-axis from y-axis and x-axis respectively. The idea with polar is instead of a distance, we do an angle and we extend a ray. So we start with a single point, the pole. We extend a ray from that, typically where the positive x-axis would be. And that is the polar axis. So we have a point, we extend a ray. So that's our pole, that's our polar axis. And then each point is defined by a distance to the pole and an angle. So r and theta instead of x and y. So how far is it? Pardon me, and what angle do I have to use to get there? So for example, we'll be asked to plot, we'll start with 5 comma pi over 6. For these, you'll be able to sketch them in freehand. I've got this handy dandy little stamper thing. Let's see. Not bad. Okay, so let me sort of darken in. It happened to fall on a line too. Okay, so there's our pole, and there's our polar axis going this way. So each of these lines is 1 unit apart. The distances are the same each time. And these count, if I recall, by 15-degree increments. So to go to 5 comma pi over 6, I'll find my pi over 6 angle. So pi over 6, that's 30 degrees. So 15, 30. So this is the sort of direction we're heading. This is our angle theta. So there's our pi over 6, and then I'll go 5 units out. So 1, 2, 3, 4, and 5 units out. So that is where the point lies. And we'll just try a few more of these until we kind of get used to the idea. And it's also going to show us a couple things along the way. So next we'll plot 2 with pi over 4. So pi over 4, so remember that is 45 degrees, and we're going out 2 units on the 45. try one with a 5 pi over 6. So there's pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, and 2 more. So here is our 5 pi over 6 angle. So there's our angle. And our distance is just 1 from the center. So there's our point. And we'll try next -2 pi over 2. So pi over 2, that's as usual our 90-degree angle here. And -2, as you expect, instead of counting up 2, we will count down 2 on that nice pretty 90-degree angle. So it's still a way to identify points in a plane. It's just a different way of getting there. So I invite you to try to plot 3 comma pi over 3, 2 comma 3 pi over 2, and my apologies, I wanted a 2 there, 2 and 7 pi over 2. So go ahead and pause the video, see if you can plot those points. Okay, welcome back. So we'll start with our 3 comma pi over 3. Pi over 3 is 60 degrees. So 15, 30, 45, 60. So there's our 60-degree angle. And we'll go to 3 on that. So there's 1, 2, and 3. So next one, 2 comma 3 pi over 2. So 3 pi over 2, we loop all the way around to the 270, and I'm going then 2 units in that direction, 1, 2. And notice that landed us right on top of another point that we already did. That was the same point that we saw with our -2 and pi over 2. These guys spit out the exact same point. So one thing that's different about polar coordinates versus rectangular is the representation is not necessarily unique for any point in the plane. Similarly, our last one with 2 and 7 pi over 2, well, here is 1, 2, 3, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, and then 2 in that direction. I just looped around. So we did here's our 4 pi over 2, 5, 6, 7 pi over 2. So we just made basically a big spiral and still went 2 in that direction. So that also landed you in the same spot as your previous point. So while I gave you 3 different looking points, you really were only plotting 2 points. So next up, we can be asked basically to create those other points ourselves. So they give us sometimes different criteria that they wanted to have. So here's the point they gave us. So a radius of 4, an angle of 7 pi over 6. So one of them they want, let's see, r to be greater than 0, and 2 pi less than or equal to theta less than 4 pi. So for starters, I want to kind of find what our original looks like. So let's do a quick sketch of that. I'll kind of darken in our pole and our polar axis again. So the original 7 pi over 6. So pi would be 6 pi over 6, and then 30 degrees more than that. So here's our 7 pi over 6 angle. And we want to go to 4 on that. So there is 1, 2, 3, and 4. So they want the same point, but they want us to keep a positive radius, so it's still going to be a 4 for the radius. Only they want us to go between 2 pi, so we need to make a full lap around, but less than 2 full laps around. So all we'll do there is we'll add 2 pi to our 7 pi over 6. So that's 7 pi over 6 plus 12 pi over 6. So that would be an angle of 19 pi over 6. So then 4 comma 19 pi over 6 would be the equivalent point. So make a full lap around. There's 2 pi, a half lap around. So there's 3 pi, or 18 pi over 6, and then add 1 more pi over 6 to that, 19 pi over 6. They might ask us to do the same thing, only say this time they want r to be less than 0. So we'll have a negative 4 on there. So basically we'll need to be heading in the opposite, have an angle in the opposite direction of this one. And what else do they specify on this one? Negative 2 pi less than or equal to theta less than 0. So in other words, we're spinning backwards. So I want to be spinning backwards. So here's negative pi over 2, here's negative pi, negative 3 pi over 2. And I want to be just opposite this. I want to form sort of a straight line with this. So here is, let me kind of put the points I'm talking about on here. So here's negative pi over 2, which is the same as if we're spinning in the positive direction as a 3 pi over 2. So then here is negative pi, negative 3 pi over 2. And then I want to go 30 more degrees in that direction. Oop, my apologies, 60 more degrees in that direction. So negative 3 pi over 2, and I want to take off 60 more degrees, so minus another pi over 3. So negative 3 pi over 2. So that would be negative 9 pi over 6. And I'll subtract off 2 pi over 6. So negative 11 pi over 6. So I'll just use a straight edge. So my angle, negative 11 pi over 6, I keep capping my negative 11 pi over 6. That has me heading in the wrong direction, so I'll have to make the radius into a negative 4 as requested, radius less than 0. So next we'll take a look at how to go from polar to rectangular. This one I don't need the fancy little stamp guy. This one I can just kind of sketch things out. Alright, so here is our theta, here's our radius, and if I drop a perpendicular down here, this is still x, this I can still think of as y. And then we have some of our basic trigonometric relationships still exist. So for example, the cosine of theta would be x over r, and the sine of theta would be y over r. So equivalently then, I can say that x is r cosine theta, and that y is r sine theta. If r is less than 0, in other words, we're spinning 180 degrees from where we actually want to be, basically, then we know that then the point that was in the form r theta, where r was negative, would be equivalent to opposite of a negative. This flips this over to a positive. Again, because r is less than 0. So it looks like a negative. Opposite of a negative, though, is really a positive. And that would be 180 degrees from the original theta, so then theta plus pi. So we just spin a half revolution. And then we go from there, same as before. So for example, we're to rectangular. They may give us, what did I pick? 12 and negative pi over 6. So x is r cosine theta. Y is r sine of theta. So cosine of negative 30 degrees would be a positive root 3 over 2. Sine of negative 30 degrees is negative 1/2. So the rectangular coordinate version would be 6 root 3 and a negative 6. I'm going to invite you to try another one again. So convert. So this is polar to rectangular. So negative 7, 5 pi over 3 to rectangular. So I invite you to pause the video, try it out, unpause it, see how you did. Okay, welcome back. So here, 5 pi over 3. Let me go ahead and sketch that since r is negative here. So 1 pi over 3 is 60 degrees. So 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. So that's our original angle. So then we want to be 180 degrees from that. So that is 2 pi over 3. So this would be equivalent to doing a positive 7 with a 2 pi over 3 angle. So x is equal to 7 cosine of 2 pi over 3. Y is 7 times the sine of 2 pi over 3. Cosine of 2 pi over 3 is negative 1/2. So 7 times negative 1/2. And y equals the sine of 2 pi over 3 is positive root 3 over 2. So our coordinates negative 7/2, positive 7 root 3 over 2. And just as you would hopefully expect, since our point was in Q2, if we went around to 5 pi over 3 and counted backwards 7, that would put us in Q2. So our x was negative, our y was positive when we converted. So next we work on converting between rectangular and polar. Again, I'll do one of my world famous, not super fancy drawings. So here's our angle theta, here's our x, y, and r. To go from rectangular to polar, we remember our buddy Pythagoras. So x squared plus y squared is r squared. If I want one of our basic trig functions to involve just x's and y's, that would be the tangent then. So tangent of theta is worth y over x. So then if I want to find out what theta is, theta would be then the arctan of y over x. So quick example there. So let's start us with the rectangular coordinates of x negative 11 over 2 and the y 11 root 3 over 2. And we want to go polar with that. So then x squared plus y squared equals r squared. So 11/4 plus, let's see, 121/4, my apologies, 121/4 plus 121 by 3 all over 4 is worth r squared. So that is 4 times 121 over 4 equals r squared, so r is 11. So we have a radius of 11. So then we can use the tangent to find the angle. So tangent of theta is y over x. So the 11s and the 2's drop. So tangent theta is negative root 3. So then theta is equal to the arctangent of negative root 3. So I'm looking for a spot where basically the sine is root 3 over 2, and the cosine is a negative 1/2. So if I formally do the arctangent thing, arctangent only keeps me negative pi over 2 to pi over 2. If we kind of reason it out with saying just this part, that tangent of theta is negative root 3, so then that tells me that one of two things is happening. Either sine theta is root 3 over 2 and cosine theta is negative 1/2, or that sine theta is negative root 3 over 2 and that cosine theta is our positive 1/2. So if the sine is root 3 over 2 and the cosine is negative 1/2, we're here at, that would be 2 pi over 3. If the sine is negative root 3 over 2, cosine is positive 1/2, then we're here at, that would be then the 5 pi over 3. Now the original point was in Q2. Use this guy. So then our radius was 11 and our angle was 2 pi over 3. If we did this using the strict definition of just using the arctangent and then moving around by sort of half circles, the arctangent of negative root 3 gives you negative pi over 3. So an alternate way, if we did this, if we followed this path, then it would at first say theta is negative pi over 3. But negative pi over 3, that's right here. If we want to land, though, in the correct quadrant, notice this one we were in Q2, not Q4. We just go ahead and add 180 degrees to that. So negative pi over 3 plus pi, so 3 pi over 3 is 2 pi over 3. So you can either use sort of the more formal definition of it, or you can just kind of sketch it out real quick. I find sketching it out a little bit easier. So the next thing they have us practicing with is transforming equations between rectangular and polar. So same rules as before. X is r cosine theta, y is r sine theta, x squared plus y squared is r squared, and tan theta is y over x. So for example, they might give us the polar equation that r is 24 sine of theta. Then, excuse me. Well then, if I multiply both sides by r, then we get r squared is 24r sine of theta. R sine of theta, that is a y. So we have 24y on one side, and r squared then is x squared plus y squared. So x squared plus y squared is 24y. If I wanted to actually get a better picture of what was going on here, we can tell by the 1x squared and the 1y squared this is likely some type of circle. So x squared plus y squared minus 24y is worth 0. And we can just complete the square. So half of negative 24 is negative 12. Square that, and we're at a 144. So this is x squared plus y minus 12 quantity squared is worth 12 squared. So this is a circle with a radius of 12, and it's centered on 0, 12. Next one, burning through the paper here today. Next one we'll look at 16y x squared y is worth 1, and we'll convert that guy to polar. So 16 is just 16 anywhere. X squared, though, if x is, remember, r cosine theta, then x squared is r squared cosine squared theta. Y is r sine theta. And we're still equal to 1. So we can just put some of those together. So r cubed cosine squared theta sine theta is worth 1/16. So that would be an example of the polar equation equivalent to this rectangular equation. Let's see here. Next one, y squared is 8x. Remembering that y is r sine theta. Y squared then is r squared sine squared theta. 8 is just 8. X is r cosine theta. So this one they might set to 0. R squared sine squared theta minus 8r cosine theta is equal to 0. So that would be an example of turning that rectangular into polar. All right, so from section 9.1, I would recommend 11 to 83 on the odds. If you have any questions, please get in touch with me. Otherwise, I will see you next time, and stay safe out there.